P. Jansi Nikita, B.Tech second year ECE in our college. My subject I am going to discuss about probability theory and stochastic process. In this subject, we have discussed properties of autocorrelation function. We will see properties of autocorrelation function. First property, consider that a random process x of t is at least wide sense stationary. Wide sense stationary means expectation equal to constant, means x bar equal to 0. That is, the autocorrelation function Rxx of t1 comma t2 is a function of only the time difference tau equal to t2 minus t1. First property we will see. The mean square value of x of t equal is e of x square of t equal to Rxx of 0. It is the autocorrelation function at mean. It is equal to the power of the process x of t. We know that x of t, Rxx of tau equal to e of x of t into x of t plus tau. It is the autocorrelation function of if tau equal to 0, in tau it is replaced 0 in tau place. Rxx of 0 equal to e of x of t into x of t. Here it is tau. Why this tau can replace with 0 means tau equal to 0. The mean square is produced, e of x square of t. Next, second property. It is the second property. Autocorrelation function is maximum at origin. Mod Rxx of tau less than or equal to Rxx of 0. We will see proof. Consider two random variables x of t1 and x of t2. X of t2 of x of t defined at time values t1 and t2. These t1 and t2 values are positive or negative. X of t1 plus or minus x of t2 whole square greater than or equal to 0. Expected value means it can applied expectation e of x of t1 plus or minus x of t2 whole square greater than 0, greater than or equal to 0. Expanding the square separated expectation, it can be represented a plus b whole square formula. A plus b whole square equal to a square plus b square plus 2ab. It can be expanded in this a plus b whole square formula e of x square of t1 plus x square of t2 plus or minus 2x of t1 into x of t2 greater than 0. Next, continuation. Simply using linearity of expectation. E of x square of t1 plus e of x square of t2 plus or minus this expectation is expanded in three terms to e of x of t1 x of t2 greater than 0. Next, e of x square of t equal to rxx of 0. It is the first property. Rxx of first property e of x square of t, we can substitute Rxx of 0. This is also Rx of 0 is substitute plus or minus 2 Rxx of t1 comma t2 greater than or equal to 0. Given that x of t is a wide stationary, means tau equal to t2 minus t1 to Rxx of 0 plus or minus to Rxx of tau greater than or equal to 0. Dividing with 2, these two are cancelled because of dividing 2. This gives two inequalities, Rxx of 0 greater than or equal to Rxx of tau, and Rxx of 0 greater than or equal to these Rxx of 0 greater than Rxx of tau is positive or negative either. Next, we will see third property. Rxx of tau is an even function. That is Rxx of minus tau equal to Rxx of tau. You know that Rxx of tau equal to E of x of t plus tau. It is the autocorrelation function. This tau is replaced with minus tau. Then Rxx of minus tau equal to E of x of t minus tau. Also, let u equal to t minus tau. This u tau is t is replaced with u of u plus tau x of u. Rxx of minus tau equal to u of x of u into x of u plus tau. Or this can be written as Rxx of minus tau equal to autocorrelation function of Rxx of tau. Next, fourth property. If a random process x of t has a non-zero mean value, if x of t is not equal to 0 and ergodic with non-periodic components, consider a random process x of t with random variables x of t1 and x of t2. Given the mean value is e of expectation of x of t equal to x bar not equal to 0. Then the autocorrelation function is Rxx of tau equal to e of x of t into x of t plus tau. That equal to tau replaced with 0. That tau equal to t1 and t2. E of x of t1 into x of t2. Since the process has no periodic components, because mod tau tends to infinity, the random variables becomes independent. Limit mod tau tends to infinity, Rxx of tau equal to expectation of x of t1, expectation of x of t2. This expectation can be expanded to terms. Since x of t is ergodic, means x bar, limit x Rxx of tau equal to mean of the ergodic x bar square. Fifth property. If x of t is periodic, then its autocorrelation function also periodic. X of t equal to x of t plus or minus t naught, or x of t plus tau equal to x of t plus tau plus or minus t naught. Autocorrelation function is written Rxx of tau plus or minus t naught equal to, this tau can be replaced with tau plus or minus t naught. Given x of t w as Whiteside stationary process can be written in this form. Rxx of tau plus or minus t naught equal to Rxx of. It is the periodic, the autocorrelation function. Sixth property, if x of t is ergodic, has zero mean, means autocorrelation function equal to 0. Limit mod tau tends to infinity, Rxx of tau equal to x bar square, where x bar is a mean value of x of t if x bar equal to 0. This mean square also 0 in this autocorrelation function. It is the seventh property. The autocorrelation function of a random process Rxx of tau cannot have any arbitrary shape. Means this autocorrelation having no shape. The autocorrelation function Rxx of tau is an even function and has maximum value of at the origin. Rxx of tau is also related the power density spectrum of the Fourier transform. The form of the spectrum is not arbitrary, hence the autocorrelation function cannot have an arbitrary shape. Next, eighth property. If a random process x of t 0 mean has the DC component y of t equal to a plus x of t. Proof. Given a random process y of t equal to a plus x of t, Ryy of tau equal to e of x of t. It is the autocorrelation function with respect to y. E of a plus, this can be written in this form, in this equation. It is multiplying with both terms and expectation with respect to these terms, and these constants expectations are 0. We can produce that Ryy of tau equal to a square plus Rxx of tau. Ninth property. This is the last property of autocorrelation function. If the random process z of t is always a sum of x of t and y of t, z of t equal to Rx of t plus y of t. Next, Rz of tau equal to expectation of z of t into z of t plus tau. This can be multiplying both terms. Expectation can be represented in these terms. All this can be expectation with respect to Rz of tau equal to Rxx of tau plus Rxy of tau plus Ryx of tau plus Ryy of tau. These all are about 9 properties of autocorrelation function. Thank you.